the reason why the Statue of Liberty is green. And isn't that great? I mean, you know, MSU, I think they're tied to the color green, aren't they? So this is a great experiment to be doing for the Michigan State University Science Festival. Before we start, I'm gonna give you a list of materials that you can assemble, and then I'll talk a little bit about the chemistry that you're going to be seeing, and then we'll go ahead and do the experiment. So I'll go ahead and share the screen for a second. Right. Well, maybe I can't. Hold on. That's all right. Well, we won't worry about sharing the screen. I can talk about things without the presentation. But for the experiment, what you're going to need, you're going to need a styrofoam plate. You're going to need some. Oh, we got it here. We got it here. Let's see. It's going to be PowerPoint. I don't see it on there. That's okay. Oh, here it is. That's what I want to share.
Okay, it should be the screen. Hit share and then just pull up the PowerPoint.
Pull up the PowerPoint. All right. I think we're going. I think it's still got me here. That's okay. Well, Hazel, are you seeing my screen or are you seeing me?
I can see your screen. You're good.
Okay. All right. Thank you. Great. Okay. So we're going to be talking about the chemistry of Statue of Liberty. This is just my contact information. If you want to check out my YouTube channel or my Twitter feed. I'm a professor of chemistry at Spring Arbor University here in Michigan, about 45 minutes south of Lansing. The materials you're going to need are listed here. Take a picture of it if you don't have your materials assembled. And then you can go get them while I'm talking about the chemistry part, but you'll need a styrofoam plate, some water, ammonia, baking soda, some pennies, paper towel, aluminum foil, a 9 or a 6 volt battery. You get some steel wool, buff up the pennies, make them shiny. That's a little helpful if you can do that. So what we're going to be doing is we're going to be making a green coating on some copper. And copper is one of the elements on the periodic table. It's element number 29. It's a metal. And when copper metal gets exposed to the atmosphere over a really long period of time, it forms a green, Michigan State, or sometimes a blue. I know some of you may not like to hear that, but I went to the University of Michigan, so I like to see the blue color that forms on the surface of a copper metal. And they call that a patina, a green coating that forms on copper metals. And there's just some pictures here on the screen. On the right, that's a rock. That was here, a rock, well, a piece of metal, I should say, that's found here in Michigan. And you can see the green coating, and then there's a plaque on the left. And there's an old saying, an old Danish saying that says when a young architect makes a copper roof, by the time his hair turns gray, the roof will turn green. So this is a well-known phenomenon that's been occurring for a long time. But what's interesting about it is this process used to take place over decades, over tens of years. And then after the Industrial Revolution, when we started to emit more pollutants into the atmosphere, it actually turned out that the formation of a copper patina, of copper exposed to the atmosphere, it doesn't take quite as long. And that's because we release some compounds into the air that weren't there at the same level before. Things like sulfur dioxide, that's released from volcanic emissions, but that also gets released now from burning various fuels. So if you look at your pennies, if you have any pennies with you, some of them might look really shiny and some of them might look kind of dark. And the shiny pennies, those are kind of more like what you'd see, regular copper metal look like. But over time, you'll notice the penny on the screen on the right, that's an old penny. It looks kind of brown. And that's from the formation of a compound called cuprite. It's forms when copper reacts with oxygen in the atmosphere. And it's got like a little brown color. And if you take your steel wool, and you just scrape off the penny, you'll be able to scrape off that layer of cuprite, and it'll come right off and your penny will look shiny. And the experiment works a little better if you do that. Now, if the penny continues to react, the cuprite on the penny can continue to react, and sometimes you'll see greenish or bluish colored things, the patina. And here's the formulas on the screen. They're kind of complicated, but they all contain copper. And there's things like bronchentite or antlerite or atacamite. These are just different names for different blue-green, or aqua-colored copper compounds that form on the surface of copper. And what's neat about this experiment I'm going to show you is we're going to be able to form a copper patina on a penny in just a few seconds. Well, maybe about a minute, but it happens rather rapidly. It happens rather rapidly. So let's leave this screen up for a while. We'll throw that back up at the end. Let's go ahead and go to back to stop the share, and let's check out the experiment. Okay. So what I'm going to do, I'm going to do the experiment with ammonia, and because I'm using ammonia, I'm wearing gloves and I have some goggles on. If you're not going to wear gloves or goggles, you're going to want to do the experiment with baking soda and water. I just like the results a little better that I get with ammonia. So I'll show you two different ways to prepare things. I'm just going to take a little bit of ammonia, and I smell a little bit of fumes when I use ammonia. We're going to pour that into a cup, and then I'm going to add a pinch of table salt, about a handful. Okay, in that goes, and I'll swirl that around. Now, while that's dissolving, I'm going to go ahead and show you how to do the same thing with water. If you'd rather use water rather than ammonia because you don't like the fumes, we'll just take a little bit of water and pour it in. We'll also take our salt, put in a little bit of salt, and then we're going to take a little bit of baking soda and we're going to sprinkle that in as well. And then we'll just swirl it around. So if you're using the baking soda, you can go ahead and use the baking soda water version. I'm going to go ahead and use the ammonia version for the rest of the experiment, but just follow along with the same thing. All right. So now, let me get that swirled and dissolved a little bit there. There we go. Now I'm going to take a paper towel, cut off a piece. I'm going to fold it in half a couple times. And we'll dip it down into the water, get it nice and wet. There we go. I'm going to squeeze out the excess. All right. Now we'll place this on our styrofoam plate. That's where the action is going to happen. I'm going to get a piece of aluminum foil. That. We'll fold it in half. And I'm gonna, well, I guess I don't need the plate. That was, I guess we don't really need that. Well, we'll just put that there in case you don't want to get your countertop messy. I'm using a lab table here, so it doesn't matter if it gets messy. Anyway, we'll go ahead and put the paper towel on top of the aluminum foil like that. All right, and you want to make sure that there's some aluminum foil on the outside. And now I'm going to take this is where the fun starts. I'm going to take my penny, and this one has been shined up really well with steel wool. You just might want to buff it like this to get the shininess there. And I'm going to place it, I think I'm going to place it face down because I want the patina to form on Abraham Lincoln there on the penny. Okay, now I'm going to get my battery. And I'm using a 6-volt battery. And I'm just using a 6-volt battery so you can see it better. But you can do the same thing with a 9-volt battery. And you're going to have to pay attention. One of the terminals has a plus on it, and the other one has a minus on it. We want to stick the plus terminal on the penny, and we want to stick the negative terminal, that needs to go on the aluminum foil. And I like to put my ear down when I do this. You don't want these, you just want this to touch. This is going to touch the penny. This is going to touch the aluminum foil. And I'm going to listen. And if I hear some fizzing, I know things are working. Oh yeah, I put my ear down there. I can hear some fizzing. I know I got it right. Let's see what happened. Let's see what happened. I'm going to pick this up. Oh, wow, look at that. I see some blue stuff there. Sure enough, that blue stuff is an indication that some copper from the penny went into the paper towel, and it formed, well, it formed, I guess, a patina on the paper towel, didn't it? And I'm gonna do this a couple times in different spots with the penny. Hear the hissing. Yep. Do it third time here. And I got 3 blue spots. I sure do. I sure do. And now I'm going to take that penny. I'm just going to stick it right there. I'm going to watch. We're going to see what happens. And while this is going, I might play around with a few more pennies. But if we watch this, you might notice the development of some blue. Oh, there it comes. Is it coming already? Let me stick my reading glasses on so I can see. Well, it might take a little while. Let me try another penny while that one's cooking. Compounds in the atmosphere are now reacting with this penny pretty rapidly to form a patina. A little bit of a blue-green color. And sometimes it takes a little while, a couple minutes, and if you leave it over a couple days, it can end up looking really blue-green. Let me pull a couple of them that I made this morning. Did the same experiment. We'll put these pennies over here. These have been developing since early this morning while I was testing everything out. I can see some compounds developing on this penny. Let me see if I can pull it up. Oh yeah, if I hold it like that, I think you can see the blue. Actually, it's kind of a greenish. Oh, I see some blue in there too. Hopefully all of you are seeing some of this as well. Let's do another one. Oh yeah, that's really starting to kick into gear. See, it takes a little while, but it's worth the wait. Now I'm going to try a 9-volt battery. The bigger terminal, the bigger, fatter one, that's your negative terminal. And then the smaller one, that's going to be your positive terminal. I'm going to pop this on here. And remember, the positive terminal, that goes on the penny. And the negative terminal, that goes on the aluminum foil. And I hope I hear some hissing, because that tells me it's working. Oh, yeah. Let's see. Yeah, we got a little bit of a blue spot. Oh, that's really looking green now, isn't it? It sure is. Statue of Liberty chemicals forming right before your eyes. You don't have to wait 5 years. You can see it in a couple minutes. Yeah, we'll let this one develop. And while this one's developing, I'm going to do some more experiments. You see, what's interesting about copper is when it's a metal like this, it behaves like a metal. And what's actually going on here in this particular experiment is the copper metal is undergoing what we call oxidation. What does that mean? Well, it means that the copper metal is reacting with stuff in the atmosphere, probably stuff from the paper towel, and that copper metal is getting changed into an ion. And what's interesting about copper metal, when it becomes an ion, it can either form an ion that has a +1 charge or a +2 charge. And when copper metal goes to the +1 ion, it gets like a red or an orange or a brown color. And so that's why you see the old pennies. Here's an old one. That's why you see them kind of go brown over time. So it's kind of get a brown color to it. Actually, it's this one, isn't it? Yeah, this is the one that's got the brown color. Because it's been, the coating of it, I should say, has been changed to copper with a +1 charge. Copper, when it has a +2 charge, turns blue or green. And so what we're seeing here is evidence of the copper metal having been changed to a +2. +2 is blue. Hey, that rhymes. A +2 blue copper ion. And there's a trick you can do if you got your hydrogen peroxide. There's some chemistry that you can do with hydrogen peroxide and copper 2. See, what will happen is the copper 2 can react with the hydrogen peroxide and it'll go to copper 1. So we're going to try this. I'm going to pour a little bit of some of this hydrogen peroxide onto some of these blue dots. I don't want to do it on my pennies because I want to keep the nice patinas on them. So I'm going to get those out of the way. I like the blue-green color on those. So I'm going to take a little bit of this hydrogen peroxide and we're going to pour it on the blue copper 2 and see if we can't get it to react and go to red or orange or brown copper 1. Oh, look at that. Right away, that's a rapid reaction. The copper 2 is getting changed to copper 1. And the evidence of that is it's turning like an orange or a brown color. And that's indicative. That tells me that it's probably copper 1 ion that's formed, similar to the copper 1 that forms on an old penny, rather than the nice shiny copper metal that we see on a new penny. So here, let's get them in order. There's our copper metal. There's our copper 1. There's some copper 1. And there's a penny with some copper 2 on it. A nice progression there. All right, there's one more experiment I want to try. I've never tried this one before. I don't know if this is going to work. I always like doing that sometimes. And that's what's fun about doing these types of experiments is there's a lot of different ways. You're probably imagining a lot of different things to try with this particular experiment. There's a lot of different things you can do. A lot of variations on this experiment. What happens if you do it in the cold? What happens if you do it with warmer water? All sorts of things to try. Anyway, this is what I want to try. I wonder if I can't make designs. So what I have here is I have some pennies arranged on a paper towel. And we're just going to soak this paper towel with my ammonia mixture. Is this the ammonia? Yep, that's the ammonia. See, that's the way a chemist tests for something, whether it has an odor or not. We don't put our nose down in something and take a really big sniff, because that'll sniff an ammonia like that, that'd be really strong. So what we do is we wave over the top of the material, and that waves the gas particles towards us, and then you can smell it and it's not quite so strong. So when I do that, I can tell, yep, this is ammonia. So I'm going to go ahead and pour this onto my paper towel. And see, I know that copper is metallic, and so is aluminum. And so these substances, they conduct electricity really well. And I'm wondering if I can't get the electricity from the battery to conduct all the way around all these pennies. And I can make a whole bunch of blue dots in the shape of a heart all at once. I don't know if this is going to work. I think I'm going to have to hold this down pretty tight. We'll see. Maybe one of you can try this. And if you get it to work, you send me an email. Okay, so what do I got to do? I got to put the positive on the aluminum. Oh, they're both aluminum. I want to put the positive on this part here, because that's going to go conduct to all the pennies. And I'm going to put the negative on this pan here. I'm going to try to press down. See if we can't get this to work. I hear hissing. I'm pushing down on it. Hopefully it's going to conduct all through all of the pennies. I can still hear it. What do you think? You think it's going to work? I don't know. Let's find out. Let's see if Dr. K's experiment worked. Doesn't look like it, does it? I think, you know what? I think my paper towel is too soaked. It didn't work. Well, I learned something new. I learned I might have to try something new next time to try to get this to go. I think I might need to squeeze the liquid out a little better. I'm gonna just try this one more time. Maybe we should just try putting that baking soda stuff on there. Maybe that'll work. Yeah, here, let's do this. Let's try. Maybe, did I do it the right side? The blue on that? No, it's not. I'm gonna just try to soak it up a little bit. There we go. Because I see a little bit of blue color forming, just a bit. I'm gonna soak up some of the excess liquid. Look at that. That's interesting. I see the outline of the pennies on there. That's interesting. That tells me I might be getting somewhere with this. That's kind of cool. Wow. That's really cool. I want to see. I just learned something that I didn't expect. Found a way to make a blue colored heart on some paper towel. All right, let's see. We're going to try it now with the paper a little more dry. Here we go. Positive on the aluminum. Pushing down. Oh boy, I can feel the bubbles. I can actually feel some bubbles. All right, let's see. Let's see what happened. Boy, it's close, isn't it? Hey! I think I just needed to make sure that the paper towel was dry. Look at that. I made a blue patina heart out of a bunch of pennies. Sure enough, here's your design. I guess I could make it copper one by pouring peroxide on it, but I kind of want to keep it blue. I like that blue color. Well, I want to thank you for watching. And if there's any questions folks have, I'd be happy to answer them.
Yeah, if anyone has any questions, you can put them in the Q&A or the chat.
Oh, and I should mention we have another presentation, right? At 1 o'clock.
Yes.
We're going to be doing some experiments at 1 o'clock that you shouldn't try at home. I'll be doing some more experiments with copper. We're going to see what happens if you put copper in acid. I'm also going to be doing some experiments where I'll heat some of these blue-green copper compounds and see if we can actually get the metal back out, the metal form of the copper, by heating some of the compounds. And we'll do some other experiments as well.
Yeah.
All right. So thanks.
Thank
Thanks for
you.
joining.
Mhm.
Yeah.